C++ also has a keyword called switch, and it's great to use when you would otherwise write a lot of if statements. Say you have some variable that could have any value between 1 and 5, and you're going to do 5 different things depending on that value. You could write if, whatever the variable is, equals 1, and then a block of stuff you want to do, and then say if the variable is equal to, and a block of stuff. It's kind of awkward, and especially since you're asking the compiler to repeatedly test when you know it can't be true. That is, if x is 1, then it isn't 2, 3, 4, or 5. If it's 5, then it isn't 1, 2, 3, or 4. Now you could do some nesting. You could say if x equals 1, do this, else, and then some brace brackets. If x equals 2, do this, else, and then end your first brace bracket. And that way you don't have to do multiple tests. As soon as 1 is true, you'll stop doing, you'll skip all the else's. But it's ugly to read, all this nested stuff. So the switch statement lets you have that effect that it isn't tested repeatedly without having to write a lot of nested ifs. One condition of it is that the thing you're testing must be some integer type, like int or unsigned int or short or long or char, or an enum, because an enum is an integer type behind the scenes. Let me show you what the code looks like. Here's a very simple switch. Again, round brackets around the, in this case, expression, not condition. So you might say switch on x. Brace brackets, and then any number of case statements, and each one of them goes case, and then some value, like case 0. And then whatever it is you want to do, and then break. And then after all your case statements, you can have default. That's what will run if none of the case statements were matched. And then you close brace on the construct. The break is there on purpose because in C++ you have control. Here's a slightly longer switch. Again, I'm going to switch on, some variable like x or some expression like x divided by 2. And in this version of the code, we have a case for value 1, followed by a break, and then we have 2 consecutive lines that are both case statements, and no break after case value 2. What's going to happen here is value 2 will do that action, and value 3 will do that same action. So it's sort of an OR. This is a very deliberate, we call it falling through. In some cases, though, you can accidentally fall through by just having a big long block of action and forgetting to put a break at the end of it. So some compilers will warn you if you omit a break statement unless you put a special fall through attribute on to indicate you're doing it on purpose. Oh, and while compilers are being helpful, if you switch on something that's an enum that has 3 possible values, success, failure, try again later, and then you do a switch on that, but you only put in case statements for 2 of the 3 possible values of the enum, some compilers will warn you about that and say, don't you want to handle all the possible values of the enum? So that's nice of them. Now, scope in a switch is kind of unexpected for some people. Here's some variable x, and I'm going to initialize it by calling some function. So I've got this value, and then I'm going to switch on x. And if x is 0 or 1 or some other number, I'll do these things, have as many case statements as I want, each ending with a break, and then I'll have a default for any value of x that wasn't covered by my case statements. You see this sort of thing all the time. After the switch, x is still in scope. Now in the case of an integer, I don't care. But what we switch on is not always just an integer. It's sometimes a property of an object. And the lifetime of that object, if you think back to RAII, resource acquisition is initialization, the lifetime of that object may be important. So you might not want to keep something around after the switch is over. You might want its destructor to go off and for cleanup to happen. Imagine that I have some object of type thing, and again I initialize it by calling this function, and I'm going to do a switch on the results of calling its getStatus member function. Exactly how to do functions and member functions is coming a little later, but I'm telling you that's what that line of code does. T.getStatus calls the thing's getStatus member function, which presumably returns an integer, and then we're going to switch on that. And if we got value 1 back, we'll do stuff, have as many case statements as we need, and then have a default. This thing T will still be in scope at the end of the switch. And you might not want that. You might want to be able to have it go away when the switch is over. In order to fit the code on the slide, I haven't shown you what the case statements do. My guess is they would call other member functions of the thing object T. So in C++ 17, we added a new capability to restrict the scope to the switch itself. And it looks like this. in the round brackets, instead of just saying what you want to switch on, you add an initializer clause and then a semicolon. So this does a switch on thing t equals some function at stuff, which is the line that used to be before the switch, semicolon, which tells the compiler, oh, that was the initializer, and then t.getStatus, which is what you actually want to switch on, the status of the thing. The rest of the switch is exactly the same, but now when you reach that close brace, t is no longer in scope. The same as in the for demo you saw earlier in this module, the loop variable I was not in scope after the for. Here, the switch variable t will not be in scope after the switch, and that means its destructor will have gone off, its resources will have been freed. It's a very powerful technique when that matters to you. If you're not worried about scope, you don't have to use initializers in your switch, but this addition in C++ 17 is very useful to a lot of developers.